March 14, 1942. Henry Ford stood on the roof of an unfinished building in Ypsilanti, Michigan, staring at what his engineers promised would be the largest room under one roof anywhere on Earth. The Willow Run bomber plant, 3,500,000 square feet, 67 acres under a single roof, 1 mile long, 1/4 mile wide. The building itself was larger than some American towns, and it didn't exist yet. What Ford was looking at was mud, steel framework, and an impossible promise. His engineers told him this factory would build one B-24 Liberator heavy bomber every single hour once it reached full production. Ford, 78 years old, a man who'd revolutionized manufacturing with the Model T assembly line 30 years earlier, looked at the muddy construction site and said something his plant manager would record in the daily log. "If we can build a car in 43 seconds, we can build a bomber in 63 minutes. It's just a bigger car with wings." That statement represented either genius or insanity. The United States Army Air Forces desperately needed heavy bombers. The B-17 Flying Fortress was good, but production was too slow. The B-24 Liberator was newer, could fly farther, carry more bombs, but it was also incredibly complex. Over 1 million individual parts, 4 Pratt & Whitney engines, aluminum airframe, hydraulic systems, electrical wiring, defensive armament, bombing equipment. Each bomber required 500,000 man-hours to build using traditional aircraft manufacturing methods. Ford's promise, building one every 63 minutes, seemed mathematically impossible. Traditional aircraft factories employed master craftsmen who hand-fitted components. Each plane was almost custom-built. The idea of mass-producing bombers like automobiles violated everything the aviation industry knew about aircraft construction. But Henry Ford had built 15 million Model T automobiles by treating complex machines as assemblies of standardized parts. He'd proven that craft production was obsolete, that mass manufacturing could produce reliable, affordable products at previously impossible scales. Now he was about to prove the same thing could work for 4-engine heavy bombers. The stakes were existential. If Ford failed, American bomber production would remain inadequate. The strategic bombing campaign against Germany would falter. The war might be lost. The scale of Willow Run defied comprehension. Construction began in April 1941, 7 months before Pearl Harbor. Ford Motor Company invested over $65 million, equivalent to roughly $1 billion today. The factory building alone consumed 200,000 cubic yards of concrete, 35,000 tons of steel. The roof covered 67 acres without a single interior support column. Workers could see from one end to the other, a distance of over 1 mile. The assembly line, when completed, would be the longest in the world. Raw materials would enter at one end, move through progressive manufacturing stages, and completed bombers would roll out the other end ready to fly. The plan was brilliant in theory, but aircraft weren't cars. A Model T had about 3,000 parts. A B-24 Liberator had over 450,000 parts, each one critical, each one requiring precision manufacturing and assembly. Ford's engineers spent months breaking down the B-24 design into sub-assemblies that could be built separately and then integrated on the main line. The fuselage was divided into 5 sections. Wings were built in left and right halves. The tail section was a separate assembly. Each Pratt & Whitney R1800 engine was mounted as a complete unit. The approach mimicked automobile production, but the tolerance requirements were completely different. A car part could be off by a 1/16 of an inch and still work. An aircraft part had to be precise to thousandths of an inch, or the plane wouldn't fly. This precision requirement created Ford's first crisis. When Willow Run began production in September 1942, the reject rate was catastrophic. Over 50% of completed assemblies failed quality inspection. Parts didn't fit. Hydraulic systems leaked. Electrical connections were faulty. The Army Air Forces was horrified. They'd committed to the Willow Run program based on Ford's promises. Now they were receiving bombers that couldn't pass basic airworthiness tests. Production in the first 6 months was only 56 aircraft, far below the promised rate. Critics called Willow Run, "Will It Run," mocking the production failures. Labor unions accused Ford of incompetence. Aviation experts insisted mass production couldn't work for complex aircraft. Henry Ford's reputation, built over 40 years of manufacturing success, was at stake. The breakthrough came from an unexpected source. Charles Sorensen, Ford's production genius who designed the Model T assembly line, studied the reject reports and identified the core problem. The workers weren't incompetent, they were victims of inadequate training. Traditional aircraft workers spent years learning their craft. Ford had hired 42,000 workers, most with zero manufacturing experience, and expected them to build complex bombers after a few weeks of training. Sorensen's solution was revolutionary. Instead of training workers to build entire assemblies, train them to perform single repetitive tasks with absolute precision. Break each subassembly into dozens of small steps. Make each step simple enough that anyone could learn it perfectly in a few hours. Then station workers along the line, each performing their single task as components moved past. It was the ultimate application of Ford's assembly line philosophy. A worker didn't build a wing. They installed one type of rivet in one location on the wing structure as it moved down the line. Another worker installed a different rivet. Another installed hydraulic fittings. Another connected electrical wiring. By January 1943, the system was working. Quality reject rates dropped from 50% to less than 5%. Production accelerated. The factory was building bombers, not fast enough yet, but consistently. Sorensen then implemented the second phase, speed optimization. Study every workstation, time every motion, eliminate wasted movement, optimize tool placement. The goal was to shave seconds from each task. When you're building complex machines with 450,000 parts, saving 1 second per part translates to massive time savings overall. By mid-1943, Willow Run had become the most efficient aircraft factory in the world. The production rate climbed steadily. In January 1943, 75 bombers. In March, 120. In June, 190. Each month, the rate increased as workers became more skilled, processes were refined, bottlenecks were eliminated. The workforce peaked at 42,600 people. They worked 3 shifts, 24 hours per day, 7 days per week. The factory never stopped. Raw aluminum entered the south end of the building. Completed bombers rolled out the north end. The average time from first rivet to finished aircraft dropped month by month. By August 1943, Willow Run was completing 1 bomber every 108 minutes. Still not the promised 63 minutes, but dramatically better than traditional methods. The traditional aircraft factory took 30,000 man-hours per bomber. Willow Run was down to 10,000 man-hours and falling. Then Sorensen made a final optimization: the parallel assembly approach. Instead of one main assembly line, create multiple parallel lines for major subassemblies. Build 4 fuselage sections simultaneously. Build both wings at the same time in separate facilities. Then bring all components together for final integration. This multiplied the effective production capacity. In December 1943, Willow Run produced 365 B-24 bombers, more than 1 per day. In March 1944, they hit the target, 453 bombers in 31 days. Average time, 63 minutes from start to finish. The numbers at peak production in mid-1944 were staggering. Willow Run consumed 600,000 pounds of aluminum per day. The factory used enough electrical power to supply a city of 100,000 people. The paint shop applied 43,000 gallons of primer and paint monthly. The assembly line moved continuously at precisely calculated speeds. Too fast and workers couldn't complete their tasks. Too slow and production fell. Sorensen's team had calculated the optimal line speed to the exact foot per minute. Material logistics were a marvel of planning. Over 15,000 suppliers provided components. Pratt & Whitney engines arrived by rail from Connecticut. Propellers came from Ohio, instruments from Massachusetts, tires from Akron. The Willow Run plant operated the largest private railroad system in America, with 50 miles of track and 42 locomotives moving materials between the factory and the main rail lines. Trucks made continuous runs between Willow Run and Detroit, carrying parts from Ford's other plants. The synchronized supply chain meant the factory never stopped for lack of components. Storage space inside the plant was minimal. Parts arrived just as they were needed on the line, a concept later called just-in-time manufacturing that would revolutionize global industry. But in 1944, it was just called the Ford system. The workers at Willow Run came from everywhere. Farm boys from rural Michigan, women whose husbands were fighting overseas, African Americans who'd migrated north for war jobs, teenagers too young for military service. The average age was 32. 40% were women, working jobs previously closed to them. Rosie the Riveter wasn't just propaganda. She was real, working 10-hour shifts, drilling, riveting, assembling bombers that would fly over Germany. The women workers were initially met with skepticism. Could they handle the physical demands? Could they maintain the precision required? The answer was yes, often better than male workers. Women had smaller hands, useful for reaching into tight spaces. They tended to be more patient with repetitive tasks. Within months, all female work crews were outperforming mixed crews on several assembly stations. The social impact was profound. Women earning significant wages for the first time, proving they could handle men's work. This wartime experience would later fuel the women's rights movement of the 1960s and 70s. But in 1944, they were just building bombers, one rivet at a time, knowing their work was helping win the war. The B-24 Liberators, built at Willow Run, flew in every theater of World War II. European skies, North Africa, Pacific Islands. They bombed German factories, Japanese shipping, Romanian oil fields. The 15th Air Force, based in Italy, flew almost entirely Willow Run Liberators. The 8th Air Force in England operated mixed fleets of B-17s and Willow Run B-24s. Bomber crews knew which factory built their plane. Willow Run aircraft were marked with a distinctive production code. Pilots developed opinions about different manufacturing sources. Some preferred Consolidated Aircraft's B-24s, built in San Diego using traditional methods. They claimed better fit and finish, fewer mechanical issues. Others preferred Willow Run birds. They appreciated the standardized construction. If something broke, replacement parts from any Willow Run bomber fit perfectly. Interchangeable components, the core of Ford's philosophy, meant easier field repairs. In combat, maintainability mattered more than perfect paint jobs. A Willow Run Liberator could be repaired and back in the air faster than a handcrafted Consolidated aircraft. The statistics supported this. Willow Run bombers had slightly lower mission availability rates when new they needed break-in time, but higher availability after the first 10 missions. The standardized construction meant fewer unique mechanical failures. Ground crews learned to work on them faster because every aircraft was identical. By the time Willow Run stopped bomber production in June 1945, after the war in Europe ended, the factory had built 8,685 B-24 Liberators, roughly half of all B-24s built during the war. Peak monthly production was 493 bombers in May 1945. Peak single-day production was 19 bombers on March 24, 1945, one bomber every 75 minutes, 24 hours straight. The fastest single aircraft production time recorded was 56 minutes from first component to completed bomber rolling out the door. That record, set in April 1945, never appeared in official statistics because it represented a one-time optimization, not sustainable production. But it proved Henry Ford's original claim. If you could build a car in 43 seconds, you could build a bomber in under an hour. It was just a matter of perfecting the process. The total program cost approached $1.2 billion. Each bomber cost approximately $138,000 to build at Willow Run. For comparison, Consolidated Aircraft's B-24s cost $175,000 each. Ford's mass production approach cut costs by 21% while producing higher volumes. This cost efficiency meant the Army Air Forces could buy more bombers with the same budget. More bombers meant more missions, more bombs dropped, more pressure on Germany and Japan. The strategic impact of Willow Run went beyond the bombers themselves. The factory proved that complex weapon systems could be mass-produced using industrial techniques. After the war, this lesson was applied to fighter jets, missiles, even nuclear submarines. Modern military-industrial production traces directly back to Willow Run. The factory's influence extended beyond military applications. Ford's manufacturing innovations at Willow Run spread throughout American industry. The concept of parallel assembly, refined at the bomber plant, was adopted by appliance manufacturers, construction equipment makers, even electronics companies. The standardized parts approach became universal. By the 1950s, almost every American manufacturer had adopted some version of the Ford production system proven at Willow Run. The just-in-time supply chain, developed to keep bomber production running smoothly, became standard practice. The training methods, breaking complex jobs into simple, repetitive tasks, became the model for industrial workforce development. Willow Run didn't just build bombers, it built the template for post-war American industrial dominance. When Henry Ford stood on that rooftop in March 1942, staring at a muddy construction site, he was looking at more than a factory. He was looking at the future of manufacturing. The mile-long building that seemed impossible became the symbol of American industrial power. The bomber every 63 minutes that seemed like insanity became reality. And the workers, 42,000 ordinary Americans, many of them women, most with no manufacturing experience, proved that with the right system, anyone could build the weapons that won World War II. Willow Run operated for only 3 years as a bomber factory. But those 3 years changed warfare, changed manufacturing, and changed America forever.